In this video, we're going to evaluate the integral of secant of x over the square root of sine of 2x. So in the numerator, the argument of the function is x, and the denominator is 2x. So let's take care of that. It's going to equal here, that's secant of x dx. And we want the same argument if we can here. So we know there's an identity for sine of 2x. Sine of 2x can be written as 2 sine of x cosine of x. And in general, for integration, I prefer to work with sine and cosine, or if possible, secant and tangent. So what I'm going to do here is I'm going to multiply the numerator by secant of x, and I'm going to multiply the denominator by the same thing, but in a different form. So this would be secant squared of x. So it's secant of x over secant of x, because the square root of secant squared of x is secant. So multiplying by the same thing, so it's secant over secant is 1. And we'll see how this works out then. So in the numerator, I have a secant squared of x. I know the derivative of tangent is secant squared. So it's nice to have a secant squared in the numerator. Now this is going to multiply through. I got this in a square root and this in a square root. So this is going to multiply in here. And remember, secant and cosine have reciprocals. So if I take this under the radicand, so let me do it this way. So this comes in under the radical here. And this becomes, I'm going to put it this way. Secant and cosine are reciprocal, so I can replace the secant squared over x, or the secant squared of x, by 1 over cosine. So I can have 1 cosine here, and 1 over here. Again, it's 1 over secant squared, and then replacing that secant squared by cosine times cosine. So this is going to cancel here, and it's going to give me the square root. Sine of x over cosine of x here is tangent. This is 2 here in front here, so this is tangent of x. Again, secant of x here, and the square root of secant squared here, just the same thing, because the square root of secant squared is secant of x. And then under the radical, it becomes secant squared, because it's square root and square root. And then I change that to, because secant and cosine are reciprocal, is 1 over cosine squared. And I just break up the cosine squared. 1 goes under the sine, and 1 will cancel this one over here. And then sine over cosine is tangent, so I get this here. From here on, I'm going to use the substitution. U equal tangent of x. So du would be the derivative of tangent is secant squared of x dx. So now let's transform the integral then. Secant squared of x dx right here. Secant squared of x dx. That's going to be your du. Du here. And that's over the square root. Tangent, that's your u. So this is going to be 2u. Then I'm going to break this up this way. This will be the integral of du. And then this can be broken up into the square root of 2 and the square root of u. That's u to the 1/2, so I can take that to the numerator, and that becomes u to the negative 1/2. So I get there, and then on front of the integral here, I'll have 1 over the square root of 2. So 1 over the square root of 2. And I'm going to integrate then, add 1 to the negative 1/2 here, simple integration with respect to u here. So this will give me u to the positive 1/2 when I add 1 to that. And then I divide the coefficient then by 1/2, so this will give me 2 over the square root of 2, and then it's plus the constant of integration. And then I can rationalize this by multiplying the bottom here by the square root of 2 and the top by the square root of 2. I'll get 2 square root of 2 over 2. The 2 will cancel, and I'll get the square root of 2 here. I rationalize this. And then this is u to the 1/2, and u is tangent of x. I can write it to the 1/2, or I can write it as a square root, like this, plus c. So I could write the answer as the square root of 2 times the square root of tangent of x, plus the constant of integration. Or I could, since this is a square root and this is a square root, I could write this as the square root of 2 tangent of x plus the constant of integration. And that's your final answer. Thanks for watching. We'll see you next time.